Hello everyone. We will be continuing today the second part of the introduction to the engineering mechanics. Where we left in the last class, we will be continuing from there. Okay. In the last class, we studied what is force. Okay. Different system of forces, that is coplanar, non-coplanar systems of forces. Then we understood the principle of transmissibility. Then we understood what is equilibrium conditions. Okay, we understood the principle of equilibrium. We try to understand the characteristics of the forces. Okay, that is magnitude, direction, line of action, and the application of forces. This is what we uh, tried to understand in the previous class. So today we'll go in the further details and we'll try to understand. Okay, so resultant of force. Okay, consider that on an object two or three forces have been applied. Okay, two or three forces have been applied, and we are applying with a different magnitude. The magnitude of these forces are different. Two, we're trying to move it for the object is trying to be move forward. What we can do is we can replace all these three forces, okay, by one force, okay, such a way that it has a larger magnitude and it has the same effect that of the what effect all the three other forces were been giving. Okay, the same effect will be there of the force on that body, but we are replacing all the three forces and we are bringing up a single force. Okay, that force will be of higher magnitude and it will have the same effect of the those three forces which were the three forces were applying. Okay, that force, the single force we apply, okay, that is called as resultant force. Understanding what I'm saying? If there is an object, okay, this is an object, we are applying the different in directions, we are applying the forces like this. Okay, and the body is moving in this path. Okay, where the body is moving in this path. Now I apply a I remove these forces and apply a single force in such a way that, okay, in such a way that after replacing the force, the magnitude of this force will be higher and it will make the same effect as that of the other three forces. It will make the body to move in the same direction which the other three forces are making it to move. This force is called as resultant force. Okay, this is called as resultant force. It is nothing but a resultant force. If a body is acted upon the different forces by the different forces, for example M, P, A, Q simultaneously, it is possible to find out a single force R which is would be replaced them, that is this single force can produce the same effect as produced by the all the forces. Consider that this is the object O, okay, and we are applying the force in this direction is Y and the force X in this direction. Okay, so now if I want to replace this force X and force Y, okay, what I will do is I will bring the resultant force such that it will make a same effect as that of, okay, as that of X force and Y force. This force is called as resultant force. Right? This force is called as resultant force. Understood? This is what a resultant force is. It is very important because we'll be solving some problems on this. Okay, where we are given the such, okay, we are given such a resultant force. Okay, we are given a resultant force, and we have to find the its components in x direction and in the y direction, that is your vertical direction and horizontal directions. Okay, when we are trying to find its component of the force, it is called as resolution of force. It is called as resolution of forces. It is called as resolution, where here in the resultant force two components are being given, and we are finding the main force or the single force. Okay, that is called as resultant force, where resultant force is given and we are trying to find out the two forces or two components of the forces, that it is called as resolution of forces. We'll be coming to it in the next coming slides. Okay, next is moment force. Moment of a force. Sometimes what happens is when you apply the force on an object, the body moves, it is in the motion. Okay, and sometimes when you apply the force on an object, okay, it rotates. Okay, there is a rotational effect on that object or the body, that it is called as moment. That rotational effect is called as moment. It's nothing but moment. The forces acting on the rigid body may either have a motion or rotation, or both rotation and motion. So tendency of a force to rotate the object is called as movement, right? I said the force which makes the object or the body to move or rotate is called as movement. So how we can measure this movement, that how much movement is being applied over this body or any body? If there is a movement over a body, so uh, how can we find the magnitude of that movement? So there is an example for you here. Consider that this is your a door, okay, and it is fixed at the point A, right? A door is fixed. Suppose consider there is a hinge here at point A, and now I am applying a force F at the free end. This is a fixed end, and this is a free end whose length is L. When I apply the force, okay, there is a movement, right? The you can see the curve, right? You can see the curve. When we apply the force at the point free end, okay, the the door rotates in this direction, right? It is rotating in this directions, right? This rotation is nothing but movement. Okay, this is movement produced by the force. Okay, so now this is an example of what is a movement. Okay, when the force is applied on the door at the free end, okay, the door swings. So this swinging of the door is a movement because we are applying the force. One more thing, as the application of force is nearer to the fixed end, okay, it might be here, it might be here, the force requirement is more and the moment goes on reducing. As you go nearer to the fixed end, understand this, as you go nearer to the fixed end, okay, in this direction, the force required for the movement is higher, and the movement magnitude of the movement goes on decreasing. At the certain point, the movement becomes becomes zero. Which is that point? The point is the fixed point. When you apply the force at the fixed point, there is no movement effect. So that time the movement is called as zero. Okay. And how to find out the magnitude of the movement. That is, we are applying the force here, right, at the free end F. We know the distance. Okay, so this is how we can calculate the movement about the point A. Movement about A is equal to the force applied. Okay, I'll rub all these things and once more. The moment about the A is equal to the force applied into the distance from that point, from where you want the movement. I want the movement from the point A. Okay, and what is the distance between the point A and the point of application of force? It is L, right? It is L. So force into the vertical distance or perpendicular distance, because the force is making a perpendicular distance to the object, right, or the body. This is the door is a body, right, and we are applying a force. It is making a perpendicular angle. Okay, it is making a right angle. So that distance, okay, the distance between the force and the perpendicular distance between the force and the movement point, that is called as movement, where you can calculate the magnitude. Okay, this is what I was saying that what is the movement about the x, a, it is force into distance. The distance should be the vertical distance or the perpendicular distance of the point from the line of action of force. The line of action of the force, okay, should be perpendicular to the distance. Okay, perpendicular distance. Okay, so if it is not a perpendicular distance, you can't take that as a length. Okay, and okay, and the SI unit of the movement is kilonewton meter. Okay, because if you can see the formula, it is force into length, right? So what is force? What is force? Force is kilonewton or newton, right, into meter. Length is in meter, so kilonewton meter. What is the unit of force? It is kilonewton. And what is the newton unit of length? It is meter. So when you multiply, you get kilonewton meter. This is an SI unit of movement. So we'll come to the resolution of forces. I have explained what is resolution of forces, but we'll try to understand once more. Resolution of forces means determining the components of the given force in two directions in the same plane. The component should be in the same plane, right? If you see, this is a force F, okay, and we are trying to determine the horizontal force component and vertical force component of that object. Okay, and we know that one angle will be given. It might be along the force and the vertical component, or the force and between the horizontal component. Okay, now how to find out? I said that we are going to solve the problems on this resolution of forces. The main force F will be given to you, and you have to find out the vertical and the horizontal components. Here there are two types of problems you will be able to see here. Okay, that is when the theta is between F and the horizontal component, that is along the x direction, and one more is the angle between the F and the y direction, that is vertical component. Okay, the formula will little bit change. Okay, now understand this. Whenever on whichever line the theta is there, if it is along the x axis or the horizontal line, then your formula will be this. It is F cos theta. Okay, that will be a horizontal component. Why? Because the theta is between the horizontal line and the force. Okay, and your vertical component will be F sine theta. Okay, understand this, that whenever the theta is between the force and the horizontal component, then your horizontal component force will be F cos theta. Okay, it will become cos. Hmm. If the theta is between the vertical component in the y direction and F, okay, that time your F will become, or your V will become, that is your vertical component will become F cos theta, and H will become F sin theta. Okay, this is the difference in the formulas. Whenever the theta is between x direction, x axis, and or in the horizontal uh, component and the force, then your H will be cos theta. Okay, F cos theta. If it is in the vertical uh, y direction or vertical component and between the forces, then your V will become, in whichever uh, uh, whichever direction the theta is. If it is in the vertical direction, V will be cos theta, and if it is in the horizontal direction, along the horizontal direction, then it will be H cos theta. This you are going to remember. Okay, this is a difference in the formula. Okay, so let's try to solve some problems over this. It is said that find out the horizontal and the vertical component of the forces. Okay, the 15 kilonewton force acts at 30 degrees, okay, to the x-axis. Okay, now this is what the force is acting, and this is what the angle is made by the force along the x direction. So as I said, if it is making a theta is making along the x directions, then your formula will be, the force along the x direction will be, to calculate that formula will be 15 cos that will be theta, that is how much, 30, right? And your F will be, V will be 15 sin theta, right? It is the formula is given here, right? F cos theta, because the theta is making an angle along the x direction. Okay, this is what the answer will get. Simple substitution is there, where the force is given as 15, you substitute 15 and cos 30, you'll add, you get this answers, right? We'll go for the next. Next is, you have to same, you have to find out the horizontal and the vertical components of the following forces. Okay, where the force is 55 kilonewton and acts at the 60 degrees to the y-axis. Okay, now the theta is between the force and the y-axis, that is vertical component. So what will happen here? Your V will become F cos theta. What will become? Your V will be F cos theta, and your H will become the F sin theta. Okay, this will be a difference. So with this formulas, this is your formula. When you substitute the values into these formulas, you will get the answer, right? This is what the answer is. Okay. uh, this is all about the first unit, the introduction to the engineering mechanics. Okay. uh, Please see that you understand, you study the definitions and solve the problems. Okay, because 15 marks from this will be asked into your final exam. Okay, thank you.